Let's use another example. Here we have an inertial observer. Okay, if we are looking from this reference frame, that means the reference frame of this girl, this reference frame is an inertial reference frame because the girl is at rest with respect to the ground. Inertial reference frame. If this girl starts running away from this object that we are looking at it, okay, if this girl starts running, but she runs at a constant velocity, yeah, still we would say that the reference frame is inertial. So inertial reference are such frames that are either at rest or that move with constant velocity. Both these kinds of reference frames are called inertial reference frames. Let's take a look at non-inertial reference frames now. Non-inertial reference frames would be those reference frames that are accelerating. Okay, so if any frame is accelerating, it's moving, and that motion is accelerated motion, only then we would call it a non-inertial frame of reference. So where u or velocity is changing with time. Only in such a case you would call these as non-inertial reference frames. I've shown you an inertial frame for this setup. So there is a pendulum hanging inside. And this inertial observer is observing this. An observer sitting inside this compartment or standing inside this compartment. Now, if this compartment entirely is accelerating with a acceleration, that means this observer is also accelerating with a, yes or no? So if now I'm looking from this perspective, I am accelerating. The reference frame itself is accelerating. So all the things observed from this reference frame would be things observed from a non-inertial reference frame, because this reference frame is accelerating. Now, there comes a problem. If an inertial observer is observing something and she lists down all the forces that are acting on it right now at the moment, and then the same exercise is done by a non-inertial observer, there will be a difference in their lists. So how to compensate for that difference, how to account for that difference so that both these people give us the same result? That is where the concept of pseudo force comes into picture. So whenever, see, all the laws that you're going to study will be valid only for the inertial frame of reference. You cannot apply Newton's laws in non-inertial frames of reference unless you account for something called the pseudo force. Just remember this part, okay? That all the laws that you are going to study in mechanics, in classical mechanics, would be for inertial observer or inertial frames of reference. All those laws would be valid there only. Laws like force equals mass into acceleration, Newton's second law. You've already seen this. Valid where? Valid only for the inertial observer, not for the non-inertial observer. Does that mean non-inertial observer cannot calculate the acceleration of things? That's where the concept of pseudo force comes in. So this is a trick that scientists use so that even the non-inertial observer is useful. Okay, even this person can come up with data which is not wrong. What is this? How to use this? All that you'll study when you go in class 11th. For now, we'll pause